In the future, most people on the planet will be living in big cities. 80% of the world's population will eventually move to big cities. So understanding cities is pretty critical.
What we've set out to do in Chicago is to provide an instrument that's available to the science community.
Now you can put incredible amounts of computing right there where the data is generated and process the data right as it comes in. This is an array of things node, and there are several great pieces of computing in here. We think of the array of things as a Fitbit for the city, a way to automatically measure and understand the performance of the entire urban landscape. Putting sensors in that let us understand what's happening with the air quality, what's happening with traffic, with pedestrian movement, and better understanding where we live.
Imagine an intersection that can calculate the trajectory of all the vehicles that are coming at it, and notice that one's coming too fast to make it, or maybe they're going to blow through a red light. So what we're going to do is hold off on the walk sign and the green light going the other way so that we can avoid an accident. Essentially, let all four directions stay red while this car barrels through the intersection. Those kind of calculations are going to require HPC right down on the street corner. There won't be time to send the data back to a server somewhere and wait for the answer.
You can make a local decision very quickly.
And it never gets transmitted back or saved in some database somewhere.
This notion of taking parallel computing and moving it out to the edge and then doing machine learning is very exciting. And it's happening all over the place. When you hold up your cell phone to take a picture, you notice that there's a little yellow box around people's faces, right? That's because your phone is recognizing what's in the scene and recognizes where there are faces. And so this loop of being able to train, do machine learning, understand things, and then send that back is a new cycle for high-performance computing.
Ladies and gentlemen, please welcome Director of the Urban Center for Computation and Data, Argonne National Laboratory, Charlie Catlett.
Thank you. I want you to know that that's called the hero shot. I only learned that during the filming, and it took some practice. I've been part of this community for a long time. Started at NCSA back in 1985, went to my first supercomputing in 1990. In the last 5 years or so, I've been focused on cities and trying to figure out how do we take our computer science and computational science capabilities and apply them to the challenges that cities have. Not just 5 million person cities, but cities of all sizes. So I'd like to sort of walk you through in just a few minutes what we've been learning in that journey, and then introduce our panelists to have a discussion about opportunities for the HPC community related to cities and urbanization. When I first there's no monitor here, so you're seeing. So I have these slides memorized. So when I first started looking at cities, one of the things that struck me was some of the work that Karen Cito, Froelich, and others have done looking at urbanization and its impact on the planet. What you have here on the sides of the screen is visual evidence of the impact of urbanization on the planet. And this is Landsat imagery. So red is vegetation. You can see lots of red on the left. Gray is concrete and other things. So as you look at this image and that 25-year sequence there, you can see the impact. You can imagine what you can't see here, the impact of the cars and trucks that are driving on the roads through that, the making of the concrete and the building of the buildings in those cities, and this is the Pearl River Delta. You can also imagine that some parts of these cities are great places to live, and some parts of these cities are not so great places to live. Now, in the middle there, you see what I thought was a sort of clever way to illustrate, one thing to illustrate, the difference between the cities that most of us live in, that are established economies, cities have been around for a while, and the cities in the developing economies around the world. And you see Chicago compared to Delhi and Shanghai. This is interesting work. The team looked at 40 different cities and divided the cities into grid of 11 by 11. For each of those grid squares, they looked over a 10-year period at nighttime light, and that's movement left to right, and the density, the tallness of buildings, the amount of steel and concrete, which is bottom to top. And you can see this kind of growth around the world. Now, I do work at Argonne National Laboratory, and we think about energy and infrastructure and environment and water. But I also work at the University of Chicago. We think about economics and finance and public policy and other things. And that combination of disciplines in Chicago is what inspired me to think about pulling together activities around cities. And the first thing that we looked at and noticed was, when you look at a city, it is not a monolithic thing. It is a collection of neighborhoods. And where you live in that city makes a huge difference of what your experience is. In these maps here on the left, you have life expectancy in Chicago with a span between dark red and light yellow of about 15 years, just from one neighborhood to another. The next map here is asthma in Chicago. The red areas, over 20%, in some cases over 40% of residents have some form of respiratory disease. The green, under 9%. You start to analyze the data and try to ask why this is. You see other data like this transportation map, the color-coded map there. If you live in the green areas there, it's a 30-minute or less public transit trip to the center of the city where the jobs are. If you live in those gray areas, it could be an hour and a half. So where you live also impacts the amount of opportunity that you have. Now, we began to work with the city of Chicago just analyzing their data and looking for ways to optimize city services. The graph that you see there is the work of Allstate Insurance and City of Chicago and Argonne optimizing food safety inspections. And you can read about it on the web, but that difference in these two curves between the normal way of inspecting and a new ordering, risk-based ordering, is catching violations about a week in front of the normal inspection process. So an improvement in the rate at which we can find food safety violations and then fix them. And a week is a long time for there to be a food safety violation in place. In the middle, you see, when I think about, from the engineering point of view, resilience and sustainability, my mind goes to water and infrastructure. But if you look at the Rockefeller 100 Resilient Cities program, you can see a much more balanced view of resilience that includes healthcare and opportunity in economics. So these all fit together into making cities better for people who live there. Now, in this community, if I go back to the 1980s and I think about, I was at NCSA from 85 until 99, and we had an industrial program. And who was it that was using supercomputers in the 80s? It was the oil companies. It was climate modeling. It was, of course, the physicists, engineering companies. In the 1990s, data started getting larger in the service sector, and they came on board and started analyzing their data. In the 2010, we started seeing life sciences come in, and then more recently, a lot of emphasis on machine learning and bigger data. And I would propose to this community that you think about a new area in the next few years, which is thinking about cities not as the individual aspects of cities that I showed you on those graphs, but as integrated systems, as complex systems that can't be studied by just pulling one system out and not looking at it in the context of an entire city. Now, you probably have, most of you, if not all of you, have heard of the DOE Exascale program. We're even able to get a program going in that in the exascale program to try to begin to build a framework for different computational models to be coupled together at multiple scales to look at long-range forecasting for cities. You're going to spend, you know, in these 100 acres, you're going to spend a few $100 million to build some new things and rezone and maybe augment public transit. How do you know that that plan is actually going to do what you think it's going to do? You don't really know until 10 or 20 years later whether you did it right. So could you forecast using computational models and at least eliminate some of the approaches that would be particularly bad? So on our panel, we have a couple of people that I want to introduce in a moment. I would say I tried to bring people together to represent different ways of thinking and looking at cities. Here in Chicago, you know, I think about our work in terms of three large buckets, one of which is using computational models for long-range planning. The second is using data, machine learning to do predictive analytics and optimization. There you see crime prediction, spatial crime prediction. And then, of course, on the right-hand side, probably what I spend most of my time thinking about is how to create an instrument to help people study cities, and that means scientists, policymakers, and residents. So Pete will be talking about the Array of Things project and the underlying platform we developed at Argonne to do that. But let me introduce our panelists, and they'll come up as I introduce them. First is Deborah Lamb from Georgia Tech University. Give her a welcome. Welcome. I met Deborah a couple years ago at Mansions on 5th in Pittsburgh. I was there visiting Carnegie Mellon University, and Deborah was at the time the Chief Innovation and Performance Officer for the city of Pittsburgh, and actually the first one that they had. And she also wrote their first technical plan. She was named as one of the top 50 women in technology during her tenure there in Pittsburgh, and now she's leading some smart city efforts at Georgia Tech University, partnering with cities like Atlanta. Next, I've invited Michael Mattmiller. Michael, give him a hand too. Welcome, Michael. I met Michael a couple years ago through colleagues at the University of Washington. Michael's background is in cloud privacy and security, and he came on as Chief Technology Officer a few years ago. This year, he was named one of the 40 under 40 high-performance people in Seattle. So welcome, Mike. And then lastly, I'll welcome Pete Beckman. So Pete and I have worked together for about 15 years on various projects ranging from supercomputing to urban sensing. Give Pete a hand. We practice that so much, we want to get all the mileage we can out of it. So, you know, I'm going to ask Deborah to say a few words about some things that are happening in Georgia Tech and Atlanta, and then we'll move into the panel.
Thank you, Charlie. Hello, everyone. It's an honor to be here. I think I'm going to start off with just explaining what we're talking about when we say smart cities. And in truth, there are many and no definition of smart cities. But if you really want to simplify what smart cities means and what it means to you and your work, I would say is the application of technology, data, and other similar tools and techniques to improve the quality of life. Fundamentally, smart cities means people. How do we actually improve people's lives on a day-to-day basis, and how do we improve generations of lives as we go on? At Georgia Tech, we thought about smart cities in a pyramid kind of triangle scheme where there are three sides to a smart city. First is obviously the vision, whatever the vision that you want it to be, whether it's resilience, transportation and mobility, environmental sustainability, as the foundation. You know, what are you trying to achieve? And fundamental to that is the components, you know, the technology, the data, the hardware, the software, whatever that is. Notice I'm not starting with the technology, and the reason is very purposeful. If you start with the technology, that means you're starting with the solution. And oftentimes, starting with the technology as the solution means that you don't really understand the problem and how to move forward with that. So it's really important to think about, the technology as an important component, but not the end state. How do you apply the technology? How do you apply the data? As in the last side is the function, is what makes it really holistic and meaningful. The second triangle is really about the different levels and scales of smart cities. So when we talk about smart cities, it's not just as in big C city. Many of us live in communities that aren't the mega cities of the world. They're not the Delhis, they're not the Shanghais or the Londons. It doesn't mean that you can't also improve the quality of life through the power of technology and data. So you really think about the different scales of technology, even at the individual level, in terms of how do you improve decision making, all the way up to the regional, in terms of cities coming together or intergovernmental organizations coming together to think about a broader scale, because the infrastructure goes beyond that. Behind that, though, because of the complex urban problems that we face, and because of the ownership not being clearly defined, whether we think about water, transportation, or even people moving, it means that we have to get into partnerships. And these partnerships fundamentally mean different sectors coming together, different experiences and expertise coming together, and thinking about different ways to tackle a problem that might not have been the conventional way to tackle a problem. I'll tell you a little bit about some of the partnerships that we've been doing at Georgia Tech. Most notably has been with the city of Atlanta. But behind all these partnerships, we have to ask ourselves two questions when we go into a problem. First is, what is the local context? What is the goal and priority that the issue is happening? How are they addressing the issue? Who is there to address the issue? And then the second, I think, bigger question is, if Georgia Tech, or all of you, some of you, can do it better. Is there a way that HPC, or is there a way that the research can advance or improve the quality of life from the status quo that you know under the local context? And if those two answers are positive, as in you really are familiar with the local context and you know that there is a way to improve it, then that is a foundation to a very fruitful partnership going forward. And that's what we saw with the City of Atlanta work that we've been doing, where we have essentially embedded research and development into city operations in the sense that we've understood what the city's needs are, what their priorities are, and then formed a matchmaking exercise to couple it with the most advanced research that the city can move forward on. And this creates a really interesting space of projects that come out. One of which is something going on with crime analytics. Your average police officer is inundated with crime incident reports that have very, very heavy data sets in terms of trying to solve each and every crime incident report. There are very limited tools out there, there's very limited time, and ultimately there's a lot of pressure to try to address the crime in a more effective and faster way. So through a partnership with the Atlanta Police Department, we have tried to advance machine algorithms or machine learning exercises where they can find faster correlations on crime and then train the algorithm to meet a better way for police officers to write their crime incident report. Of course, the City of Atlanta is not the only relationship that we have to think about when we think about smart cities in our communities. And we're really trying to explore what about the other communities out there, not just in Georgia, but also other states, other communities outside, the Southwest, international, national. And to that regard, we've looked at a couple of programs in terms of empowering mayors across 10 different cities in Georgia to think about smart cities. We're also thinking about a wider Georgia Smart effort to improve local community partnerships and smart city endeavors throughout the state. And we really hope that that's the first of many partnerships that will come.
Thank you, Deborah.
Well, thank you, Deborah, and it's great to be with you this evening, and it's an honor to be here at the conference. I thought I'd tell you a little bit about what we're doing in Seattle around smart cities and the way that we are succeeding through partnerships. So the city of Seattle is growing rapidly. Since the year 2010 and through the year 2035, our city is expected to grow by 32%. You may have heard that our growth is driven in part by a tiny little startup called Amazon, which is taking over our downtown. But of course, as we grow, our community is becoming more high-tech. 75% of our new residents are coming for jobs in the technology sector, and they have high expectations of how their government uses technology. Behind me is one example of an app we've had in place for a few years called Find It, Fix It. It's very simple. If you see a problem in your community that needs government attention, you snap a picture, we collect some information, it goes to our Central Service Bureau, and the appropriate city department springs into action. It's an example of a lightweight way that community is changing relationship with government and a way we're becoming more efficient. But thanks to that concept Deborah just described, the smart cities concept, the concept of using technology and big data to improve our quality of life, we've been able to do some really neat things. Take, for example, sustainability and environment. We have a policy objective in Seattle to become a carbon neutral city by the year 2050. We've already done it with electricity. Our municipally owned Seattle City Light became the first in the nation to be carbon neutral back in 2006. One of the largest remaining sources of pollution we have is our downtown core, where more than 100,000 people come every day to work. So our Office of Sustainability, in partnership with our downtown business owners, began collecting data to look at how energy is consumed, lighting systems, water usage, transportation, and they began benchmarking that information so that building owners knew whether or not they were above or below their peer group. That was interesting, but not particularly smart. So we brought Amazon and Microsoft to the table. We brought Accenture and Microsoft to the table to help build algorithms and use machine learning in Azure to help identify real-time improvements that could be made to lower energy consumption. They helped deploy sensors and HVAC and lighting systems across the downtown core. And today, we've been able to realize 27 million kilotons, of carbon that we've reduced as a result of this program. We also recognize that there are ways that we can be using technology and big data that don't seem obvious. This behind me is an example of a geyser that sprung up during a sudden weather event in Seattle. And these weather events are becoming more current or more frequent as a result of global climate change. Now, you might look at this picture and not think about how technology can reduce flooding. Typically, we might think that it's a 100-year-old infrastructure, a billion-dollar capital project to improve it. But we decided to collect some data. Specifically, we deployed a series of rain gauge sensors across the city to understand how rain falls. I know that shocks everybody that it rains in Seattle, but it does. And what you can see from this chart on my right is that we learned that Seattle has microclimates. And not just small differences in how rain falls in our city, but from the downtown core, which is the lightest shading there, to Rainier Beach in the lower right, we actually see a difference of 8 inches of rainfall per year. That's the entire amount of rainfall that the city of Phoenix receives in any given year. So again, useful information. We know where rain's going to hit us the hardest, but not yet terribly smart. So we partnered with the research community. We went to the University of Washington in their meteorology program, as well as the National Weather Service. And now, from the data we collect in real time to the models we're able to produce based on historical data and other analytics, we can get a safety alert 1 hour before a neighborhood is expected to be affected by a sudden rain event. We can then roll a truck and we can take steps to protect the physical environment so that 1, we protect public safety, and 2, we protect property owners so that the city can reduce the types of liability claims that we would typically receive from property damage during a weather event. This is an example of a collaboration that we're trying to do more of, and something that President Obama encouraged through the creation of the Metro Lab Network, which is a network of city and university partners that come together to solve smart cities challenges using technology, and really leveraging that R&D experience in our universities with the deployment experience and need in our cities. Now, of course, in a city like Seattle that is experiencing rapid growth, no problem is more severe than transportation. So when we think about how do we make our city easier to get around and move people more quickly, we realize we don't have all the answers. That's why we try and partner through our community, through our great technologists, through our institutions that otherwise aren't at the table, and seek out their ideas. Last year, the city of Seattle became open by preference, meaning that any data we collect or generate through the operation of government, we strive to post on our open data portal, data.seattle.gov. So we went to our community and said, how would you solve transportation challenges, and what data do you need to build them? Over the course of 6 months, we went out and learned from our community what data they want, and then we partnered with 6 regional governments to open up 150 new transportation data sets. We threw a hackathon, and we were able to receive 14 prototype solutions that were really quite innovative and based on problems that our community saw that weren't even on our radar. The picture behind me is from my favorite team, a team that works at Microsoft, a group of individuals that work at Microsoft. And their problem was that they had to commute from downtown Seattle to the east side across Lake Washington. And the only way to get across is a bridge that didn't have bike lanes. But they wanted to ride their bike. The way they do that is they have to put their bike on the front of a bus where they have the bike racks. And yet, those racks can frequently be full and cause people to be delayed 20, 40, 60 minutes. So what they did is they hacked up a cell phone that you can see here, and they created a sensor to take imagery of the front of the buses where people would put their bikes. Using Amazon Mechanical Turk, some predictive analytics, and the real-time bus information from the city and county, they were able to integrate predictions of whether or not you could fit your bus or your bike on a particular bus into the One Bus Away app. Really an incredibly clever solution that required HPC, it required knowledge we didn't have in the city, and even new types of challenges that weren't on our radar. So as we think about the way that technology is evolving and the way it's changing our cities, there's incredible opportunity for partnership. And I sure hope that everyone in this room thinks about ways that your work and your research can benefit your communities and take steps to get involved. Thank you.
Okay, so in science we love to build instruments. From Galileo to the Square Kilometer Array, we build instruments in order to gather data. And so if we're interested in building an instrument in order to understand a city and do urban science, we have to understand, okay, what are the questions we'd like this instrument to ask or to answer? What kind of questions do we want to ask, and how do we get those answers? And so early in the Array of Things project, which is an NSF project between the University of Chicago and Argonne and other folks, we asked those community folks, what kind of things does the instrument need to provide? And of course, air quality is one of the big questions. And so we immediately started talking to folks who said, well, we need to understand nitrogen dioxide. We want to understand ozone. We want to understand carbon monoxide. But we also want to understand what's happening in the city with respect to activity. What are pedestrians doing? What are cars doing? How are bicycles moving throughout the city? And so from that description, we then went forth and said, all right, so what kind of instrument would this look like? There are sensors that exist in cities, but usually these sorts of things are big, sparse. There are not very many of them. They're expensive, and they're very, very precise. So scientists will put a couple instruments out in a big city. What we wanted to do was blanket the city with sensors. So at Argonne, there was a project that was to develop a platform, the Waggle platform, which was to design a platform that was really reliable and leverage the DOE's investments in high-performance computing, that we can run computation in the device. So this would be a programmable sensor, not just one that reports data, but that you can write programs to run in the sensor, in the device. So when you design a sensor like that, it's going in the public way. It has to look good as well. So we partnered with the School of the Art Institute in Chicago, and an artist was able to design the enclosure that you see there. And you can see a number of nodes that are being built. These are nodes that are about to be deployed and sent to Detroit. And the key thing here is that whether it's deployed in the prairie or it's deployed in a city is it has to be able to run computation out on the edge. Now, this ends up being a high-performance computing problem. So the first question Charlie kind of hinted at is, well, why do you need to run problems at the edge? Why run parallel computing out there? It's because the amount of data that we want to analyze would swamp any network. The ability to have 4K cameras, the ability to even have hyperspectral imaging, audio, all of that stuff can't be sent back to the data center for processing. It has to be processed right there in a parallel, small supercomputer. And so whether it's OpenCV or it's Caffe or it's a deep learning framework like TensorFlow or something else, we have to run the computation out on the edge. So here we have an example, a couple examples. One is a green infrastructure. The Nature Conservancy has a prairie, and they want to understand plant species that are planted on green roofs and in the prairie. And with automated computer vision led by Nicola Ferrier at Argonne and some students, they were able to automatically look at plants and in between two species determine which is which so you can plot their growth. In the middle frame was some work that's especially important for the city of Chicago, and that is flooding. And so, again, computer algorithms out on the edge, parallel OpenCV with using OpenCL in this case on a Samsung ARM-based processor, is looking at about 50 frames of image and then calculating, can we see water? And you'll see the segmentation there, the black and the white, is a computer algorithm predicting which is water and which is land. And finally, if you look at the traffic here, we're using again, a computer vision algorithm. This is a Kalman filter and some Bayesian inference in order to track pedestrians. This kind of pedestrian tracking is important for understanding car-bicycle collisions or pedestrian car interactions, understanding whether roads are slippery, are cars sliding into the intersection. These kind of tracking dynamics are very important. And the question is, what kind of code would you want to run if you could run in the parallel machine? So, of course, in supercomputing here, we love geeky hardware, and what is happening in the environment here is that all of the companies are working to develop machine learning accelerated hardware. Intel has a company now called Movidius. They make a little 1-watt chip with 16 vector units, right? So this is a 16 vector processor that can do amazing analytics of visual images. It's used in drone flights. Intel also has a company, Nirvana, that does the machine learning on the server side. NVIDIA has a processor, has 256 Pascal cores, which again is used for analyzing and doing analysis out on the edge. So the questions for us in the parallel computing world are, how do we take that parallel computing structure that we have on our supercomputers and scale it in a way that we have this virtuous loop where we can do training of large-scale data on the supercomputer and create models that are inference-based, that are quick and fast, that can be pushed out to parallel hardware that's accelerated out on the edge. So the Array of Things is working on that right now. We have many pilot projects here in Denver. There are a couple nodes. I went out last night trying to find one over on the 14th Street. I couldn't find it, but we get data from it, so I know it's there. There are some in Seattle. We're sending some to Portland. We have some in Tennessee. And we're beginning to understand what kinds of parallel programs we can send out. And the question for us are, what would we use? What kind of programs would we write? What can we do with that kind of analytics? Thanks.
Excellent, thank you. So, you know, when I started thinking about cities, there wasn't really anywhere to go for funding. There were no smart city programs in, say, 2010 or so that you could apply for money. You know, a couple years later, NSF and DOE and NIST and others started to do smart and connected communities and other programs like that. And so, you know, the programs started coming along. And then in around 2015 as well, the President's Council of Advisors on Science and Technology commissioned a working group, many of us participated in, to look at, and we reported in February 2016, technology in the future of cities, to look at how the federal government could help cities navigate the next 50 to 100 years. Recently, Michael, you had opportunity to help some of the legislators develop a bill that takes, I think, us to the next stage of opportunity, I think, for this community and others to partner with cities and do the kinds of things we've been talking about. I wonder if you could just kind of lay out what that bill does and
Absolutely. So the bill, Charlie, is the Smart Cities and Communities Act of 2017 that was developed by Senator Maria Cantwell and Representatives Susan Delbene, both from Washington State, with Representative Lujan from New Mexico signing on as a co-sponsor. So we're very thankful for their leadership and their recognition that we need to invest in funding for pilot projects and other types of initiatives related to smart cities. Specifically, what this bill does is, number one, it encourages the federal government to be more organized in how they engage with state and local communities as it pertains to infrastructure development. So for example, how do we make sure that grants and other types of funding don't preclude investment of sensors and new ways of managing our built environment that unintentionally would discourage smart cities? Number two, it includes funding. $220 million a year for a 5-year period to, number one, invest in workforce development to make sure that our communities are developing the researchers and the practitioners necessary to deploy new solutions with IoT in the built environment. Two, it makes $100 million available for pilot projects that small and medium-sized cities can compete for and win to develop some really innovative new approaches to transportation and infrastructure and other use cases. And three, it also makes $20 million a year available to the national labs for their own projects that might benefit cities and in collaboration with researchers in cities. So it's a really exciting time, and we do hope the bill comes up for a vote soon.
Yeah, you know, the PCAST report, one of the findings was there's no agency responsible for cities. So it's exciting to see this bill bring these different agencies together to coordinate. But one of the things we run into a lot of times in technology space is that we do these great demonstrations and great, sometimes one might call stunts, examples of what could be done. But I wonder, Deborah, if from your experience in Pittsburgh and now in Georgia Tech and Atlanta, if you could talk about how do we do these kind of projects in a way that we actually make a difference that sticks?
Yeah, absolutely. And I think Michael alluded to a little bit, when you think about the investments that are needed for your smart cities projects, oftentimes the investments are so focused on the capital investments, the initial burst of energy and momentum that's needed to gather the players together. But then very little thought comes into the maintenance of it, the operations of maintenance. You know, when we think about our current infrastructure, the state of our current infrastructure, you know, by the American Society of Civil Engineers, we're at the C-, D+ in terms of our bridges, our roads, our dams, etc. And I would be remiss to think that smart cities infrastructure will follow that kind of route if we don't currently now take the step now to think about what is the maintenance that's required to continue to improve the quality of life.
So now part of that, you know, you've also talked about part of this bill is workforce training. So you've also talked about workforce training as a
Yeah, absolutely. So, you know, when we think about the operations of the infrastructure, you know, what kind of training is required? So workforce development, if you think about, you know, the communities that might be benefited from the smart cities infrastructure, how could they be part of it in terms of retraining or new trainings that are done from the K-12 level, or new STEAM and STEM education programs, or veterans returning back to the workforce? You know, what are the new skills or skills that might be needed to keep up with this new smart cities infrastructure that could benefit communities beyond just the technology itself?
One of the things we thought about with the Array of Things project was, mayors sometimes change out every few years. And if you get the mayor to agree to do something that takes 5 years and he or she's gone after 2 or 3, you could be in trouble. And so we spent a lot of time building relationships. I like to say I don't have a relationship with the city of Chicago. I have a relationship with Danielle and Brenna and Tom and Rebecca and, down the line. And I've met with 7 layers of management in the city of Chicago, making sure they're all excited about our project, and they are. But I wonder, Pete, if you could talk a little bit about the experience of putting a scientific instrument in the public way. And, I'll just ask, well, how did it go, to show up and say, I'm a computer scientist, I'm here to help, trust me.
Yeah, but when I tell my family that, they also love that. Yeah, no, really, I can help. It's a difficult problem because with new technology comes new expectations, right? We've all learned about the expectations we have about people taking pictures of us and posting them to Facebook before we even have a chance to say wait, like I'm sure there are some right now that have been posted, right? And so when we talk to citizens, it's important to be able to describe the technology, but really more important is the method and the openness with which you do that. The fact that there were community groups that got together and talked about what does an instrument do? What would I want measured? I care a lot about my kids because they have asthma, so I really want to know what's happening with that. And so that openness of both the data and the policies and being able to modify those policies in an open way really goes quite far. Also, early on in the project, we had this sort of saying that if it doesn't matter to me, it won't matter, right? I want it to matter to me, right? The citizen wants it to matter to them. So in the case of asthma, there's a group we're working with in Chattanooga, and they're measuring pollen, and they're trying to use machine learning to predict when days kids should not be walking to school on those days so they don't miss class. And that's an example of, hey, here's some science and some smart city data that matters to me.
So, by the way, we're going to take questions from these microphones that have numbers on them. They'll bring the house lights up a little bit. So if you have a question, I'm going to do one more question with the panel, and then we'll take questions from the audience. Maybe I'll ask this next question, and we'll start again with Pete and kind of work our way back to me. How will we know that we've created, we have this aspiration for improving cities and somehow making them smart. How will we know that we got there? And can you sort of put your science fiction writer hat on and imagine what's the city like in 10 years where you could say our work in the last 10 years, whether it's Array of Things or some other project, whatever we're doing, our work really paid off. We really made a difference for that city. What would that look like, Pete?
Well, in 10 years, of course, if I can't have flying cars, I would at least like a city that is aware of the things that I want to get done. I want it to be as smart as the things that are now happening with respect to our house, our appliances, and our cell phone. It's still the case that we spend a lot of time trying to figure out how to get things done in the city. And I would love for the city to be responsive. So, when I'm having to use transportation, I want everything to figure out, oh, well, here's the parking spot for the meeting where you need to go, and here's how you can get from here to this other part. I want to know about the parks and what's happening in those parks, and whether there are things that will affect air quality and that I can participate in. And so I think that the same kind of intelligence that we have now, we want in the home, we want to project. Last week we had an Italian professor visiting us who said, one of the computations that they want to do is, they said, we have a problem in the city. We have these old trams, and people park on the side, and sometimes they're parking and they're just a little bit over where they should be, and then the entire tram line has to stop, and all transportation stops. right? And this is a perfect example of where computing at the edge, where a smart city would be able to tell us, wait, no, you're not done parking yet. If you still have a car that isn't autonomous by then, you're not done parking because the tram is going to come through here and you're still sticking out by 3 inches, right? So that's a real practical example of how we expect smarts to show up.
Well, and Peter, I love your vision and your example. When we think about the smart city of the future, I completely agree. We should have a built environment that is responsive to our public. It shouldn't be that one has to pull a government service, is my bus on time? You should be able to get the guidance you need to interact and move through in a seamless manner, whether that's finding out about an event or how it is that you're going to get to work that day, to how it is that the city can offer up a benefit to you that you may not have known you're eligible for. But I think what's going to be really critical and how we know that we get there over the next 10 years is how we in government are able to envision and bring those solutions to bear. Today, the city of Seattle has about 13,000 employees. And I showed that picture of the geyser up in our Capitol Hill neighborhood. It took someone who had the foresight or maybe heard from a colleague or was working with a researcher who said, that's not a capital project to replace the sewage or the drainage system. There's a way that we can use technology to iterate here and to do something that is more cost effective and beneficial to our public. So making sure that in 10 years we have a workforce that understands the art of the possible when it comes to HPC and maybe isn't doing all the work themselves but is able to reach out and collaborate with a really solid community. I think that's when we will have recognized success.
And I would build off from what Pete and Michael said and think about the scenarios that they painted in terms of the access to the technology, the skills to utilize the technology. That literacy should be something that should be available to wider segments of the population. Right now, what we are talking about when we say smart cities, it's still a luxury for a certain segment of the population or certain sectors. And we really need to think about smart cities as a collective good, a common good that is open and accessible to everyone. When we were doing our Smart Cities Challenge in Pittsburgh, we had a saying that was, if it's not for all, it's not for us. And that was very purposeful because of the very infrastructure modernization efforts that we did in the 50s and 60s, divided neighborhoods and made it even more inequitable. And so we were really thinking about how this time around, if we were to rebuild our city with smart cities technology, how we could actually make neighborhoods closer together and how we could make it more equitable.
So what would you advise people proposing to this wealth of funding that Michael talked about to make sure their projects hit the mark on that, in that respect?
I would think it's very much as how Michael said, it's a stakeholder engagement process. Bring the people together at the very start. So then they have as much ownership and responsibility at the start of the project as they have with the outcomes at the end of the project. If they're not there at the beginning, they're not likely going to be there at the end.
Great. And if I could just add briefly to that, because I think that's absolutely right, get the engagement at the start. But I'd also encourage everyone in this room to really engage your cities, your local governments. And if you've got a desire to help make your community better or to see your research get applied in practice, learn what is culturally important to that community. We've talked a little bit about equity, that it has to be a solution for all. That's critical in Seattle. It's critical that we think about civil liberties and privacy and how a community is going to perceive that new sensor that is mounted to a pole. So there's a lot of ways you can get engaged. Reach out to your electeds, your city council member. If you have a commission in your community that's run by your city or local government that focuses on technology, these are all great organizations. Just to ping them, find out what they're thinking about and how you can engage.
Let me just pick up that the cultural response to smart city technology varies widely. And in fact, as we were talking about smart intersections and traffic lights last week with this Italian professor, he relayed to us that this varies culturally in Italy as well, that a traffic signal is an instruction in Milan, a suggestion in Rome, and a Christmas decoration in Naples. And so he told us that we have to be very cautious about how we expect people to interact because it differs depending on where you are.
Let's take a few questions. We'll just start over here on microphone number 1. If you could just say who you are, where you're from before your question.
Name is Randy, and it kind of all three of it is directed to all three of it, because I don't think there's a single person in here that's not excited about technology and innovation. You showed a triangle, but I suspect that more appropriate, it should be a pyramid, because sitting underneath there is funding for all of that stuff. What are we going to do about funding? Because we have bridges collapsing that no one wants to pay for. And I just said a few minutes ago, we have smart cities, but stupid leaders. And then along to the idea of technology and innovation. So Congress right now is about to pass a law that says everyone should be able to buy a silencer for a gun. So the acoustic sensor and infrared sensor you just deployed doesn't work anymore. And in Seattle, they're very progressive. So everyone is very inclusive. So they're going to get this technology out to the city. They have the fiscal resources. I'd like welcome comments from anyone.
Well, just because you gave the shout out to Seattle, what's interesting about us is while we have the solid technologists and visionary researchers in the University of Washington, we also have a community of advocates that is very concerned about their civil liberties. So we have this inherent tension, I think, in many of our communities that can, hindrance is not the right word, a consideration and opportunity for stakeholder engagement. I think to your point on funding, the more we can align the interests of our technologists and researchers and what our city needs and where the zeitgeist of the community is, the more quickly we can move, the more sustainable we can be. For example, transportation, very top of mind in Seattle. Homelessness, very top of mind in Seattle. Any types of solutions that come to the fore that can help us on those issues and drive consensus and drive that stakeholder engagement, those are the ways we move forward and find funding.
And let me add a couple things on leaders and funding. I think one of the most important ingredients to a smart city success is executive leadership at the very top. If you don't have, a strong, mayoral buy-in or a strong city county manager, or whoever your executive is, you're less likely to succeed. And once you have executive leadership or a mandate at that top, I think things will start to be more creative in terms of funding and resources, because that's what really pulls the communities together with that common vision. A very useful chart I always look at is one, London wanted to pass the congestion pricing, that was done by Mayor Ken Livingston. It was the most unpopular initiative or mandate of all time. It was the lowest point. There was no public approval for it, and the mayor really wanted to push it forward, and he rallied, and it became a very popular initiative with lots of cost savings. And so you have to think of it differently in terms of leadership at that top, and then with funding, thinking about the savings or the different additional benefits that aren't incorporated into the initial cost at the beginning.
We got several more questions and not a lot of time, so we'll just do rapid fire, starting number 2.
Hey. My name is Ruslan. I'm a PhD student at Clemson University, and my question is following. So in a smart city, when there is a lot of troves of data collected, very detailed data, 4K cameras mentioned, a lot of sensors. How do you balance this with privacy, both when the hack happens, not if, but when, and against malicious political actors, be it gerrymandering or something worse?
You want to take that one, Mike?
So I think in short, it goes back to the stakeholder engagement. And I think that there are cities doing some really interesting work in this field. The City of New York came out with their responsible use of IoT guidelines. If you go to nyc.gov/IoT, it's a great way of framing up the privacy considerations. But I think about our own experience in Seattle, where it was about 3 years ago, we installed a wireless mesh network in downtown to provide additional backhaul to some cameras and our first responders. And our privacy advocates were convinced that this is a super secret surveillance network where we would start tracking our public using their cell phones and MAC address listening, essentially. Then we came out and said, that's not technically possible with this equipment. That's not our intent. We promise we're not going to do it. And yet these individuals went to our city council who said, we can't trust that that won't happen, and they ordered the network be turned off. So it was a good sign to us that our public didn't understand what we were trying to do. It also didn't help that 2 months later, I got a phone call from our transportation department saying that they had just installed cell phone MAC address sniffers across the city to help better manage transportation, and we had to explain that. So what we ended up doing is we did convene our public. We sought their input saying, how can we earn your trust in how we collect and use data? And the result was a set of privacy principles that our council passed that serve as the ethical framework now for how all city staff need to think about using data from our public. We hired one of the nation's first municipal privacy officers, and today she leads a team of 4 staff who make sure that we do the appropriate privacy reviews before we deploy new solutions and mitigate privacy harms. So I think the answer is we have to stay vigilant, we have to have the right frameworks in place, or we're not going to get the trust from our public to roll these technologies.
You know, I think for this community, that's an opportunity to work with cities. The staffing in cities often doesn't have the level of training or sophistication in cybersecurity that this community has. So I'd say if you're a cybersecurity person, call up your local CIO, ask him or her what keeps them up at night, and it's probably something that you're working on in a good sense. Number 3.
Dimitri Nikolopoulos from Queen's University in Belfast. My question is, how do you make all these technologies more socially inclusive and accessible to people and communities who don't have the means to invest a lot in technology?
Do you want to do that one, Deb?
Yeah, no, that's a great question, and it goes back to the resource question. I mean, fundamentally, the truth is there is not enough money for smart cities the way we want to build it. You know, there's not unlimited amounts, and the technology is ever evolving. So what we are doing is a good example with communities outside the city of Atlanta. And these are a lot smaller communities. They don't have the same level of resources. They definitely don't have the same scale. But it creates a really exciting opportunity because we are creating an opportunity where they're working together and scaling up that way. So one of the slides I showed you, it's with 10 mayors across the state of Georgia, where they're coming together to look at their resources, to look at what they could do collectively to advance smart cities technology and to advance smart cities development. And that actually forces the rest of the smart cities community, you know, the tech providers and other researchers to think of what does a smart community look like if you're not a mega or mid-sized city? What does a rural community look like if you really want to think about the advancement of technology and data to a smaller community, and how can they also be part of this ecosystem?
And let me just add one more thing, which is with respect to how we handle open source and open platforms. I mean, one of the great things that happened in supercomputing was the ability to run jobs on small Linux computers that you know, students in some small college somewhere could cobble together and do themselves, right? So part of this open access is the ability of, you know, for both the science and the tech and the software and the hardware to be in the hands of citizens that can make their own versions and adapt it for their particular area and their needs.
So we have time for one more question. I'm just going to round robin back to the second microphone.
Oh, thank you. Carlos Malzahn, UC Santa Cruz. So I live in the Bay Area, and let's say we build a smart city in the Bay Area, and then an earthquake happens. How do we, you know, as we rely on these smart cities, survive those reliances, you know, that relying on all that smartness when it's suddenly not there?
So, so I'll answer part of that just from the technical architecture perspective. So one of the benefits of computing at the edge, of, you know, distributed computing, is that there isn't a single point of failure. The ability of a let's say a camera and electricity and a inference engine to say, hey, there's something happening here, doesn't need to have that data go back to the data center where the earthquake has put it offline, right? The reason that Amazon and Facebook and Google have tens or hundreds of data centers is because distributing that infrastructure makes it more resilient. So there is part of the architecture that can be helpful. It doesn't solve the entire problem, but it does make things helpful. The second part, from a technological perspective, is there always has to be a way that a human can interact even when the tech is down, right? I mean, we have hotels that have elevators and stairs, right? And when the elevator, no matter how smart it is, isn't running, we can take the stairs. And so from the perspective of how cities design smart data, smart actuators, and infrastructure, those things will have to be taken into account so that there's reliability and resilience built in.
And I think it's also a great opportunity for collaboration with the HPC community. Much to your point, Peter, government is different in the sense that government needs to survive and be ready to provide services in these cases. So how do we help educate people who are working in this field of what that means, how we need to continue to see a technology work even in the presence of some type of natural disaster?
And multilateral stakeholders. So if one community is affected, there should be other communities or other stakeholders that can come in. Charlie's city resilience framework that he had in the middle was a really good example, because the heart of resiliency is to account for expected and unexpected shocks and stresses, and how you can bounce back quickly from that.
Well, if you'd join me in thanking the panel. And just to let you know, the gala opens around 7 o'clock. There'll be a ribbon cutting a few minutes before that. In the meanwhile, there is a big blue bear somewhere out there that they would like for you to hang out with. Thank you.